Hey everyone. In this problem, we're looking for the amount of work that an electric field has done on a proton as it has moved it between two different points of different electric potentials. So the first thing I'm going to do is find that potential difference. So I'm going to take the final potential and then subtract the initial potential. So that's negative 45 minus positive 125. And then do the units. So if we do this subtraction, then we find that the difference is negative 170 volts. Now, as for finding the amount of work using this information, we have a pretty nice formula that tells us that a potential difference between 2 points is equal to the negative of the work required to move it between those 2 points divided by the charge on the particle. So all we got to do is solve this for W, the work, that's what we're looking for, and we find algebraically that the work is equal to the negative of the charge times the potential difference. So now we just put the values into our calculator. In this case, we're looking at a proton, so Q is just going to be the charge on a proton, which is about 1.60 times 10 to the power of negative 19 coulombs. And then we multiply that by the voltage we found, the potential difference we calculated earlier. And if we put that into our calculator, then we find an amount of work of 2.72 times 10 to the power of negative 17 joules. And that is the amount of work done. Now that is in joules. The problem also asks that we answer this in electron volts as well, which, to be fair, is even easier than what we just did, because to find this in electron volts, all we need to do is take the calculation we just did, except instead of substituting in coulombs for the charge, instead we can just use E, the elementary charge, which is especially easy in this problem because a single proton has a charge that is equal to just one of the elementary charges, which means that the work is also equal to negative 1e for the charge of the proton, then times the exact same potential difference, negative 170 volts. So we don't even need to put this into our calculator because we can just clearly see that this is going to be equal to positive 170 eV, electron volts. And that is it for the problem. I hope this video helped you out. If it did, please consider subscribing, as it'll help me out in making more videos like this. And if you have a question, leave a comment down below and I'll do my best to help you out. If you have a request for a future video, or you just like to hang out, my Discord server and my Twitch page are linked in the description below, so check those out if you'd like. But that's all for now, and I hope you all have a lovely day. Bye-bye.